I don't know if you can hear me or not, so. Okay. We got it yet? Testing, 1, 2, 3, testing. Okay, we good now? Can you hear me? Okay. Yeah, I have a loud voice normally, but I know that we have like live streaming and all that stuff. So thanks Dan and Nicholas for letting us talk, and AWS for all the food and everything. So we used to work at AWS, so we like to eat their pizza. So so yeah, we're your warm-up act. So you'll get all ready for bit moving by the time we're done. We are going to talk about proxy-assisted live switching in the public cloud. And this is kind of a weird thing, but we want to try to socialize this with you, and we will explain why we think this is a good way of doing live production. Jialu and I are Port9 Labs. We're a very small bootstrapped company in Portland. We're focusing on cloud stuff, live TV audio and music production. Should I move my mic down a little bit? Yeah, okay. Am I in the wrong spot? Okay. So we're still in the early R&D phase, as the slide says, and it's actually pretty cool if you're an engineer. I consider it like engineering utopia at the moment. There's no managers, no money people, no board of directors, no product managers, nothing like that. We're just writing code and nothing to sell yet. So we exist by doing contract work at the moment. And this is like, I've done several startups before, including VC funded, and in my opinion, this is the right way to do the type of work that we're doing for this particular project, which is really over the radar type stuff. So we have some tenants because we used to work at Amazon, and Amazon always has tenants. And I'm not going to go through all of them here, but I mean, basically the idea is that IP media production is coming. It's really great. We think that it's a good place for the cloud. You should really be doing it in the cloud as SaaS. And for a lot of small broadcasters, it may be the only way they can afford IP production. And you know, I guess a good example I like to make is when we were at Elemental, we worked in the building that the Oregonian used to be in and had printing presses and stuff like that. And I think that broadcast is going to move the same way as print media, where they have less money for that type of stuff. I mean, the Oregonian right now, they don't own their printing press. It's outsourced. And they only keep the people who are, I would say, like the creative types, the reporters and stuff like that, and they've outsourced their printing. And in my opinion, I think the same thing is going to happen in broadcasting with a certain tier of broadcasters where they basically they're not going to be able to afford the IP infrastructure. And I think that if we can do something in the cloud that's really low cost, I think that it will help them. And that's really what we're aimed at. And low cost happens to fit really well with our company because we're a bootstrap startup, so we don't have a lot of money to spend anyway. So in the talk tonight, I'm going to talk a little bit about the types of cloud software that we've done before, especially me because I'm the old guy here, and sort of to see how, like, where our project fits within that kind of stuff. Then we're going to talk a bit about a live switcher project that we're working on, and we're actually going to demo it. That should be cool. We'll see how all that works. So let's get started, why not? So the types of cloud software, this is all stuff that I've lived through, so I have like the scars for every single part of this. So interesting. The first part, lift and shift. So this is, it's interesting that this slide is not mirrored, okay? But okay, I'll deal with it. I'm seeing the next slide on my laptop, I don't know why. So this is really how, like, most of the NDI demos you see on Amazon and stuff like that are happening right now, where it's basically a PC app that's running in the cloud on a VM. And in my opinion, this is actually a really nice experience for the people who are operating it. it's you know, it's a native user interface. These remote desktop protocols are actually pretty good these days. You get pretty low latency and pretty high quality. So there's really no problem there, in my opinion, when you're doing like your NDI stuff up in AWS. But the problem comes when you get like a little bit too big, you can't fit everything on an instance, or, you know, it's a scaling problem. And it's expensive if you want reliability, because you basically have that one instance, and if it fails, you know, what are you going to do? And if you look at people, you know, the reports of what people are doing, they're building like a whole other set of infrastructure to use just in case one part fails. And in the cloud, if you design things correctly, if you design things with that in mind, you can actually save a lot and not have to completely duplicate everything in order to still have resilience. So, and yeah, so that's expensive if you want reliability, and it also tends to use really expensive instances, mainly because of the GUI and stuff like that. And it's like, they pretty much, when you write this code, you pretty much can expect that you have a GPU in your workstation, and so you expect that in the cloud. And you know, in my experience, there's very little that we need to use a GPU for. So these instances tend to be pretty expensive, and you have to pay the Windows license fee in order to run in the cloud. So that's kind of the issue with that one. The next phase that oops, why is that going that way? That's weird. Next phase, the adapting phase. This is like where Elemental was when I joined them in 2012. Elemental was in the cloud pretty early, and actually, you know, in my opinion, they were doing a really good job at that time. But this part is where you start, you've already done your lift and shift, and you found some problems with it, and you start adapting. So you try to make it so that it will work better. And you know, one of the first things that happens is your user interface moves to HTML. And you know, I think you can, if you look at some current day things, you'll see this happening. And you put in an orchestration layer that is visible to the user, so that the user starts having to control it as platform as a service. So they say, you have to run these instances in order to get your stuff. And it just really becomes really complex. I mean, we had all of these discussions at Elemental. You know, the cloud should act more like the ground should act more like the cloud. And it was really hard to make the separation. And if you filed bug reports, it's like, well, can you reproduce that on the ground? And just, it ended up becoming kind of a mess. And really, I'm really into like the user experience, because I used to actually do this. I was a TD at a TV station, and you know, and I think that I really care about the user interface. And it takes heroics still to make web browsers do a good job with media stuff. And like today, what those heroics are things like WebGL, web codecs, there's WebASM, all that kind of stuff. And you can do a pretty nice GUI with it if you do all that. But then, like, it's really tough. I mean, it depends on the browsers, and it's just really nice, in my opinion, if you can, like, avoid that problem. And Jialu and I, 4 years ago, we were working on a WebRTC project, pretty big, and right before a major deadline, Firefox changed how they were doing their SDP stuff. It completely broke our service on Firefox. And it's just like, that's always made me like a little timid about, you know, relying too much on somebody else on a dependency for something that major as your user interface. And you know, that happened to be with WebRTC, and we use WebRTC now for our stuff, for some of our stuff. And you know, I think it's mature enough that you can do that. But the things like I'm talking about, the WebASM and that kind of stuff, I think is still in that category where you're really taking a risk if you're trying to do that in production right now. And then like at Elemental, we got acquired by Amazon. And all of our services had to move into this API-driven thing, where basically all you have is an API. Everything talks to the API, including the web browser. So if you were like really into like Elemental's Media Live, for example, how that looked pretty cool. Actually, that's actually what's in this picture here on the bottom. It's a little small to see. Suddenly, that actually turned into what you see there. It's just a plain text thing. And worse than that, it starts with this thing like, paste in some JSON here. And of course, you're not going to be able to see your video or anything. And so, to me, that was a real step backwards. But what really, the whole reasons for it and the whole Amazon model is that back there where you see all those instances and it says not your problem, I mean, that's the thing. It's like all of that is being managed for you, and that's a really good thing. All the scaling, everything, there's somebody else who's on call when all that stuff happens. Used to be people like Jialu. And so that's a really, really major thing about the API-driven thing. And it really takes care of a lot of things, except I think stuff like the user experience kind of suffers a little bit. So when we decided we're going to do a service, oops, I'm going too fast. We're kind of a hybrid of the AWS style, where we do have an API SDK that you can use. And it's mainly, though, for the life cycle, like creating and stopping, saying, I want to do a production. Here's how you can do it. You can do it either from a console or you can do it from an API. And we handle everything in the back. So this is true software as a service. So basically, the way that we're designing it, you can say, I want to do a live production. I need this many inputs. I have all these cameras. I'm doing these outputs. Make it happen. And so that's how we do it. And one of the things that I'll talk about through the next probably 10 minutes of this discussion is the whole reason why you see Proxy media there. And so that's one of the things that we decided that we needed to put in some really low latency messaging. So we do have a messaging bus in here in addition to like REST APIs. And that's for what I like to call the central nervous system. So the stuff that's really too fast to be control plane. Things like take on this switcher, that kind of a thing. All of those are happening on message buses, moving your audio faders and all of that, and that's what we do. But for hitting the ground with your user interface, we really want native APIs or actually even hardware control surfaces for that. And so that's really what we're designing for first. We can do the web stuff, but we really prefer the native. And so, oops, this goes twice. That's terrible. Okay, so I'm not going to stay too long on this one, but I would say GUI control, I think lift and shift probably wins on that one, and we're maybe right after that. I mean, the nice thing about it with our system is you can use the native stuff will talk to our service, and it's possible you could see that there could be multiple vendors that all build their own apps that can know how to talk to our service. So you can get some there. Bandwidth is like interesting because RDP is like 1 to 20 megabits, I'd say, depending on how complex your scene is at the time. And I think that we actually win in this one because we can send proxies down at like 1 or 2 megabits. Although, like, if all you're doing is text in a web browser, then your 1990 modem is okay. And sort of the Grass Valley AMP style in the middle uses a bunch of WebRTC feeds, and that's like 5 to 10 megabits once you add them all together. But it's still pretty good. So that's sort of the range there. And for resiliency and scale out, I mean, it's basically the moving to the right to the API based, and our stuff is where you win on those things, in my opinion. So that was a little bit about letting you, placing us within sort of the world of different way things are going in the cloud. So now we want to talk a little bit more about why we ended up making a switcher in this particular way. So this is a proxy-assisted switcher. So in this case, and this is really hard to read, but I'm going to go into, you're going to get bigger diagrams later, so don't worry too much about it. But there's basically a switcher in the cloud and a switcher on the ground In this case, the switcher on the ground is running in my laptop with a native GUI app that's going to be looking at it. You'll see it in the demo. And really, the main thing is that the switcher in the cloud is working on full res stuff. I mean, we use uncompressed. We actually use 64 bits per pixel uncompressed. We're like 16 bits per component, RGBA. So it's a full resolution switcher. And the main thing about it is that its commands are coming from the ground. So it's really like, you could think of it almost like VOD, where you have edit decision lists, where the VOD turnaround time is less than a second. Because basically what happens is edit decision lists come up from the ground by looking at proxy video, and then they get into the cloud in time for the main switcher to do its thing. And the reason we did this has to do with resiliency and scale out. And that's like, we have an overall latency of about 1 second through our service, and most of that 1 second is there to allow for lots of things to go wrong in the cloud and for us to compensate for it. So, and we're designing, and I really can't go into too much detail about that part yet because we have to file some more patent work. But you know, basically, it's a bunch of little machines, little instances that are really cheap, that all work together to create that switcher or whatever it is. And that it's really easy if some part fails, for another part to take over for that in a really easy way. And it's actually cheap that way. But in order to do that, we needed like that second to be able to give us some time to adapt. And so that's what that's for. And we'll go into this in a little bit more detail in the future. But that's really the thing that I wanted to get through, is that this is actually operating on proxy media on the ground. It's delayed so that the changes that you make on the ground are time-stamped and applied at the correct time in the cloud. So I'm going to go through this in maybe excruciating detail. I don't know. I found that some people pick this up right away. All I have to do is say what I've already said, and some people it takes a little bit longer. So I'm going to just go through these, little bit by bit in the timing. This is all having to do with the timing thing. So the way we start is what I call latency alignment. Oops, let's go back here. Yeah. So in this case, the sources that are coming from the ground can be at different latencies, have different latencies depending on how they got there. Like, let's say that you're doing a road race and some of your cameras are like, inside the car, and maybe they're using 5G, and some things are like using faster networks, and maybe you have something up in a balloon that's using something. But anyhow, we're assuming that, we can make it so that if you've time-stamped everything, we will align everything before it goes into our system. And so that's what this is, and this is why there's queues of varying depth that are there. So like the guy that's like the shortest depth is probably the guy with the longest latency. And so the point is that at the time that video frames leave this latency correction thing, they're all aligned on the same timestamp. And that's actually what goes into our system. We unify it at that point. So everything has the same time, everything is aligned in timestamps at this point if you want it. You can say I don't care, let it go wild, and we'll just go ahead and put our timestamps on it. But if you really care about it, we'll go ahead and do the thing here. But the cool thing, at least for us, is that once it leaves there, everything's in the right format and all the times are exactly the same. And the rest of our system can deal with it in a nice, clean way. So this is the first part. And a lot of systems forget this. I'm really amazed. But this is nothing that's unique to doing a proxy thing. This is just getting your sources to line up. Okay. The next thing, the proxy generator. So we take every source and we create a low-res proxy out of it. And we send it down to the ground. And this is so that the switcher is actually going to operate on the low-res version. And in our case, currently what we're doing is we actually take the same code that we use for a multi-view, and we just grid everything together, and everything with the same timestamp. We send that one frame, boom, down. And so that then gets split up in the proxy switcher, and that's how we do it. So if you looked at what's coming down there on proxy media, you would see that it's actually one grid that gets sent 60 frames per second that has all of our sources on it. And so for us, that's working really cool. And it was kind of like an interim thing. We may do something better, but it's kind of our, poor man's muxer system, I guess you would say. You certainly don't get out of sync. And every one of those frames has the timestamp on it that came up from the cloud. And that's really important because then there's a switcher that's sitting there working on those lower resolution things. And every time you make a change on the switcher, we look at what that timestamp was. And then we send back up. We say, okay, this person just started a fade with the video at this timestamp. Okay? And that's what goes back up to the cloud. So 250 millisecond delay is something that we artificially induce. Later you'll see that we're currently using wrist for this to get a constant delay. And we chose this one to be pretty constant around the world. So you could have people collaborating on this same production all over the world. And you could have one director that sees the video at frames and can issue commands at the same time as everyone around the world is seeing it. They all have the same delay. So this seemed to be kind of important. So that's what we did that for. And we used wrist for that because it was a really convenient way of getting a constant delay. And 250 milliseconds is something that we could tweak if we need to, but it seems to be pretty good. The next step is up in the cloud, all that full res stuff says induced signal delay, okay? What that is in our demo is actually a delay. There's queues in there that are queuing up the video. They're queuing up for a second. But in the real stuff, what's really happening is that we have a, flow graph of a whole bunch of instances that the video is flowing through, and we just guarantee that by the end of it all, everything will happen within 1 second. But in this case, for the demo, we're not doing that. We're just going to, as Jialu will show you, we're just doing all this on one machine, and we're faking this by putting in, we literally have buffers in there that store a second of each video frame. And from the ground then, the commands that came up, they were time-stamped, but they need to be buffered so that they get issued to the switcher in the correct time, with the correct timestamp as the video that's come in. So that's what's going on there. Let's see. Yeah, so the cloud switcher then is operating on the uncompressed stuff using the delayed commands. So sorry for people who were really understood that the first time. Because I even have more. This is, oops, I don't know why we're going by 2, but this is an example of, let's say this is the frame that we were going to do an action on at some point. So at the time it leaves the proxy generator, it also goes into our delay line. 250 milliseconds later, it shows up at the proxy switcher. And it's also, you see it's moved all into the delay line. So it's sitting there somewhere, well, a quarter second in to the delay line. When it comes out of, I don't know why I have a problem. When it comes out of the switcher, it goes up to the cloud. There's some delay there for how long it takes to get the signal up into the cloud, but it doesn't matter because we're putting it in this other sync thing, so that we're just waiting for those 2 things to both arrive at the switcher with the right timestamp, and then we'll do the action. Oops. Well, you get it. So there's where the action happens. So now we want to demo this. We'll see how well this works. We're using code that's like a year old. And Jialu and I have spent the last few days relearning how to make this code work. So this will be a cool demo, I think. So Jialu is going to talk through this part of it.
Okay, so this,
another microphone.
All right, so this is a map showing the setup of the demo today. It's basically very similar to what Mike just showed as our architecture. So you can see there are mainly two parts. In the cloud, we have a full resolution switcher running, taking the sources. And we're not using a GPU instance or anything. It's just a regular instance there. We also have some players for the sources. And we run WebRTC SFU there. We'll talk about that later. And on the ground, we have a control service here as the hardware. It's real. We also have Mike's laptop here, which runs the ground switcher, which also has a native GUI app. And between these two, for the networking, we use a WireGuard. Didn't work? Thank you. We use a WireGuard tunnel, which runs the REST proxy, which runs REST to send the proxy videos, and nets for messaging system. And for proxy, as you can see in the cloud, once the sources are coming in, we encode them to H.264 and send them through REST, which is only 1 megabits per second. And we use this fixed 250 milliseconds delay. And these proxy videos are sent to the ground that are going to be viewed by the operator on the ground. And we use nets to send our messages. That means whenever the operator on the ground wants to apply a command on a frame, and these are the proxy frame time-stamped, of course. So the switcher on the ground is going to look at the timestamp, put it in the command, and send it to the cloud switcher. These are all through nets. And that also includes property editing, like if you want to do a wipe or a DVE and other things. So now the cloud switcher gets this command and is going to look at...
Oops.
The cloud switcher receives this command. It's going to look at the timestamp and apply those commands whenever it's the time to use those frames with the same timestamp. And so here we are also running a WebRTC SFU in the cloud, which we really shouldn't. But this is here to receive the output so that we can, just for demo purposes, if you're interested to monitor our output, you can either scan this QR code or use this link. It's just a WebRTC output low resolution as well to see what's being output from the cloud switcher. And now we are going to do the demo. And Mike is going to switch to the demo setup, which will take a long time.
So yeah, we're actually running stuff you can see here I'm running this stuff in the cloud. I'm starting it.
And the demo is only going to work if he knows what he's doing.
Exactly.
He usually does.
It's so amazing. So amazing, like, whoa, okay.
So what you see here, this GUI is, this GUI is from the, it's from the ground switcher. So all the sources you see here are the proxy videos we got from the cloud switcher. Now he's setting up some sources, and this must be some layout. Fancy stuff.
This is just to show you that it's a native app, and so we'll start playing stuff, and we'll go.
Yeah.
Let's put the effects unit over here.
Right now, what he really should be showing you is the output from the cloud switcher.
Right.
But as I said, sometimes.
So so the point is, like, if I make a switch, if you see the switch on the switcher part over on the left, it should happen about a second later in the cloud. Okay. So, you know, we're about right? So that's basically what you give up in order to do this type of thing. There's a little bit of delay there, but it's not that bad, right? Okay. I mean, I would call actually our whole 1 second end to end, I would call low latency. But oh yes, we have a question.
So I pulled it up on the phone. Is this WebRTC to the phone?
Yes. Yeah, you're looking at our WebRTC coming off of SFU. We normally, we have a lot of experience with WebRTC. We would never put it on an instance that has a switcher on it normally because it's like wide open to the internet, all these UDP ports.
This is the read that would normally come to your full review or preview stream, whatever, into the program stream.
Well, for us, this is actually the switcher output, the main program output. This is just to show you, you know, the whole reason was to show you the 1 second delay, basically. And, but yeah, so this is, you know, me on the ground, and I do things like, oh, let's do a DVE, why not, okay? And you should see it happen a little bit later in the cloud. And yeah, see, like that, like kind of thing. So that's basically what all that's about. You know, other than that, this is just a native app that's our switcher. I mean, it's got a GUI that maybe only an engineer would love. I don't know if, but you know, this is just something that I wrote in order to test our stuff. But I mean, it is a native app that runs on, you know, Windows and Linux and Mac and all that. And but you know, it does test out the various functionalities of our switcher work on here just fine. And so yeah, there's a DSK. I'm sorry, what?
Do the buttons on the control surface work?
Oh, this,
don't
yes.
push.
Yes,
don't push.
these are also hooked up. These are also
Sometimes
hooked up to
they
it.
work.
And sometimes it works. Like here, I just hit cut. It worked. Okay. Whoa. Okay. Shall we try? Let's see. We'll try an auto. Okay. Yeah. Oh yeah. Okay. See. So Jialu is like really nervous right now when I'm doing
telling
this.
him don't
Because she just wrote this interface stuff. I mean, I just like, you know, for a demo it'd be great if we hooked all this stuff up. And so she like wrote this in a couple days and.
Like don't really hit the button. Just.
But in any case, oh yes, another question.
Let's do questions through the microphone so we can for the recording folks.
Sure.
Really cool demo. That switcher GUI, could you put that into like WebASM and run it in a browser?
Yeah, that's the part that I said that we were really trying to avoid, but it's totally possible. And it's just that, you know, we got burned on WebRTC when it was pretty young, and I feel like WebASM is about at that phase right now, and, you know, I'd be like really happy to wait a little while before doing it, but you certainly could. I mean, what you're seeing here, this multi-viewer is what's coming out of our ground switcher. The ground switcher is creating the multi-view. We're actually sending it over a Unix socket, uncompressed, over into the switcher, and the switcher's going up there. But that could be like a web view that shows other things, you know, really easy. And you know, the main part, but this was just so that we could exercise all of our functionality. But yeah, I'm, you know, I really like uncompressed. I like sending things uncompressed, and so that's what we're doing here. The switcher is sending uncompressed straight from, you know, multi-view straight to the GUI. But we could do it other ways. And really, I mean, the whole thing for us is like all of these inputs, everything that we're doing, that's like 1 megabit max, and we're using less than that. And so this is actually lower bit rate than what you're doing with your RDP stuff. And to me, the ease of use is, you know, could be just as good. You know, you're really not missing anything by doing this. And you have the resilience and scalability of the cloud behind all of this. And you know, that's what you bought with that second, basically. And that lets us do all kinds of stuff. And if we didn't have that second, we could probably figure out a way to do it, but it would cost us more. And we're really, we really are aimed at those broadcasters who maybe aren't going to be able to afford broadcasting unless they use a service in the cloud. So.
Yeah, I would. I obviously. I work at Paramount, and during COVID, when we had to go to remote for control room, all this stuff. I mean, this type of thing. Oopsie. This type of thing would have been critical right then. We put this together. We put cameras in front of control rooms and did set players on low latency mode to get sub-second delivery, so people can see the control room remotely in their house. Mm-hmm. This is addressing that, so thank you. I really appreciate it.
And actually, I have to give some to Elemental and Amazon, because this is actually when I learned about how important this was. It was like 4 or 5 years ago, and even back then, people were asking Amazon for this stuff. And to me, it seemed really cool. And but at the time we formed our company, we really couldn't interest Amazon in this stuff. Now they're probably interested, but at that time, so it was one of those things where it's best to go away and do it yourself, and see what happens. And so that's where we are. And it's been a lot of fun, a great learning experience, I think.
Well, it's a great use of WebRTC, because in the premium side of content, WebRTC and the legalities of sharing content across people and DRM and all this stuff through studios is a non-starter, but this is a great use of WebRTC.
Yeah. So.
Are there any other questions here? Yes.
Yeah, so on the latency, you said it's like 1 second of latency, but it seems like when you were switching, the switching latency was considerably less than that.
Yeah, it's an illusion. Well, okay. Plus, it's actually like 3/4 of a second or something, because remember, we've delayed it a little bit before it hits the switcher. But yeah, totally. I mean, Jialu and I were both in exactly that extreme, and I had to do like a screen capture and see that, because Jialu wrote the code that's delaying the stuff in the cloud. I'm telling her, you're not delaying it. You're not.
Well, because the delay getting into the cloud doesn't affect you operationally.
Yeah.
Right. It's from when you push till you go out. Right.
Yeah.
So
really, if you look at how our service is really designed, it's really weird, because and I can't talk about it too much yet, unfortunately, but we're really asynchronous. We only care about synchronous at the edges, and hopefully someday we'll be able to start talking about that, because in my opinion, that's like ultra cool. And so one of the things that having that second does is let you do this kind of weird asynchronous, but what I consider very cloud appropriate type data transfer. Yes.
Could you run this over Citrix? If I virtualize an application, like a video editing application, could I bring this back down to a monitor and run a video editing panel?
I would think so. I mean, really, what we're doing here is what's coming down from the cloud is like about 1 megabit right now it is literally H.264 packetized over RTP, sent over RIST protocol. But that's just how we chose to do it. And there's all different ways to do it. But the whole point was, we figured that we're going to assume that we're going to use 1 megabit for our proxy protocol. It kind of doesn't really matter on how you really send that. And we did have to take because we're using WireGuard, we had to change our MTU, go down to a little bit smaller size. So we're actually doing, we're sending smaller packets than we would like to, but that really doesn't matter that much, as it turns out. And I don't think the Citrix thing would be a problem. It's pretty resilient, because if you think about it, we have this induced delay, so it's really easy. Basically, it gets to the ground too early for us to want to deal with it anyway, so we have to buffer it a little bit, and that's what we're doing in RIST. And the stuff gets back up into the cloud way before we need it, so we have to buffer the commands that are in the cloud until we're ready to to give it to the real switcher. So I think that if there was more latency in those links, we could live with that just fine. Personal opinion, but I think so. And Anybody else?
All right. Any other questions? All right.
So the proxy you have to create that, how many channels can you support on your MacBook, for example?
Well, on the MacBook, this is like an amazing machine. This is one of the new, M2 or whatever. This is a fairly recent one, and it's hardly doing any work. I mean, it's amazing. I mean, it's like, maybe 5% CPU usage.
So have you thought about doing that in an embedded environment that could go to the camera?
You could for sure do that in an embedded environment. And that is like, I didn't want to mention that, but like, we did used to work at Elemental, and we knew that like Elemental made like a lot of money on hardware, and we're not like forgetting about the fact that maybe we want to do some embedded stuff.
Just saying.
Yeah, but I think it's totally appropriate for it, and these MacBooks are like incredibly fast for this type of thing. It's just really amazing. Even sending uncompressed like we're doing between processes, it works just fine. The only weird thing, about the Mac is like if I hid this switcher window, the OS will stop letting you write to the video surfaces. It's like it's probably a power saving thing. And so like you have to write the code to take that into it, to know that like sometimes the OS isn't going to let you write your stuff. And that's also true on the WebRTC views. If you start like an auto-playing view like we do, that will eventually just stop playing on the Mac. So it's like that's because of battery type things. So there's a few things like that we have to deal with. But otherwise, I think it's a great environment. And but like I grew up writing embedded code. I was at Tektronix and did all that kind of stuff. And I certainly like that environment. And I'm not saying that we're not going to go that way. I mean, compete with you, maybe.
It's not compete. I mean, I can see the application for me.
Yeah.
Great. We have one last question here we have time for, and then we're going to go to a break. Thank you, sir.
How many engineers do you have?
You're looking at them. So I think that.
Are we recruiting?
It actually, so let me say that I think that two people working together without, in an ideal environment is probably faster than 7 or 8 people working at a big company. So, I mean, I think that we've had a really ideal environment. Not to mention the fact that Jialu and I did work together at AWS, and so we already knew like how to deal with each other.
So you're not ready for a product manager?
Huh? Not yet.
Well,
so this is the point. Like once we figure out what we're doing, and we're getting close there, we're actually going to hire our managers and our executives and all that kind of stuff because we don't want to do that, okay? I want to be an engineer forever, okay?
Only because we don't know how to.
Yeah. I can tell you, like, I hate doing the budgeting and stuff like that, okay? So.
He doesn't know how to.
Yeah. Right. So really, that's where we are. I think it's a cool spot right now, but like if I was here a year from now when we were talking, there would probably be some marketing person here also, that we've had to hire. But at the moment, it's still like the great days, utopia, and we may end up hiring another person this year. We definitely have enough work for it. So.
We don't have the money.
Yeah, right. This is the part that we have to deal with that. But I mean, I'm sorry to take up so much time, but since I've done these before.
No, we're here to gather, take up the time. I don't think anyone's in a rush to get out of here.
Not having much money when you're a bootstrapped company feels a lot better than not having much money when you have VC funding. Okay, I can't tell you how great it is, and so I definitely recommend that if you've never done it before, that it's kind of fun to try a little bootstrap thing.
He's saying if you decide to work as a product manager or other managers with us for no money, please contact us.
Yeah, right. There you go. So.
And we will facilitate that through if you guys want to reach out through this forum.
Thank you for.
Yes, great job. All right, we're going to take a